Today we're going to look at multiplying and dividing rational expressions. Our objective is to be able to simplify rational expressions, that include multiplication or division of each other. So what must be true in order to simplify fractions? Remember, a rational expression is a fraction. It's just a polynomial divided by a polynomial. And the main thing you have to remember is that you can only reduce or quote-unquote cancel out factors, not terms. And this is the biggest mistake student makes, and I'll point it out to you as we go through the four examples. In our first example, it's very basic. We've dealt with this earlier in the year. And what we're going to do is when you multiply fractions is you multiply the numerators and you multiply the denominators. And I'm going to do this. Some teachers do it a different way. I find this is the easiest to make one numerator and one denominator. And to do that, we're just going to multiply 5 times 6. Because remember, when you multiply, order doesn't matter. So I can move any of these x, y, z's, x, y's, or numbers anywhere I want. So I have a 5 times a 6, and I'm going to write 30. X squared and x cubed is x to the 5th. Y times y squared is y to the 3rd. In the denominator, 2 times 20 is 40. X times x is x squared. And y cubed times y to the 4th is y to the 7th power. Now I find this is easier than, just crossing things out and reducing over here, because I find a lot of students miss things. So I like to do it this way. And now what I'm going to do is look at each part. 30 divided by 40 is 3/4. X to the 5th divided by x squared is x cubed. And there's a couple ways you can get that. You could do the rule where you take the numerator exponent and subtract the denominator. 5 minus 2 is 3. Or just think, where do you have more x's and how many more do you have? That's what you'd get if you wrote them all out individually and started to reduce. If I look at the y's, I have more y's in the denominator, and I have a power of 4 more. And that's all I can do. I can't reduce my numbers, x's or y's anymore. And that's my final answer. 3x cubed over 4y to the 4th. Example number 2 is a little bit more difficult. I'm going to show you what I mean by the difference between factors and terms. Right now, each of these separated by a plus or minus is a separate term. Okay, they're not factors. The only factors that are here that are separated is 4 times x, and there's nothing else down here. So I can look at 4 separately from x, because it's not add or subtract anything. What most students do wrong, and I'll still see it even though I'm pointing it out to you right now, is they'll say, well, x squared, 4x, let's see, 3 goes into 6, 2, oh, here's an x and an x, a 2 and a 2, and they start doing stuff like this. This is very, very illegal. Okay, do not do this. What you're doing here is simplifying or reducing terms and not factors. So please, please, please do not do that on a quiz or a test. Instead, since we have to reduce factors, I'm going to factor the numerator and factor the denominator of each one. So, and we did this earlier in the year, this is going to be a GCF of 4x, which leaves me with x minus 1. In the denominator, this is a trinomial with no GCF, so I'm going to get an x and an x in my other parenthesis. Factors of 3 are 3 times 1, and I'm going to need a positive 3 and a negative 1. Times, I'm going to do the same thing on the right. This is a trinomial with no GCF, so it's x times x. Need numbers to multiply to give you 6, but add to give me a positive 1, so I need a plus 3 and a minus 2. I cannot factor this because it's a single term. You can't factor a single term. But I can look at 4 and x separately, just like up here. I can look at 4 times x minus 1. Things that are multiplied together, you can look at individually. Those are individual factors. So now, remember, when you multiply fractions, you're multiplying the numerator and multiplying the denominator. So in essence, this is 4 times x minus 1 times x plus 3 times x minus 2. In the denominator, I have x plus 3 times a quantity x minus 1 times 4x. So I can write this as one big fraction where this is my numerator, this is my denominator. Now to reduce, I'm going to reduce any factor that is the same. And it doesn't matter where it is. A lot of students think, oh, it has to be on a diagonal. It does not have to be. Anything in a numerator can simplify with any factor that's equivalent in the denominator. So I have x minus 3, x minus 3, x minus 1, x minus 1. 4, x, x. Now I looked at those separately because sometimes the two numbers might reduce to 1, and the x's will be a different power, or the numbers will reduce to a number other than 1 where the x's go away completely. So, and remember, when you reduce, it doesn't become 0. X minus 1 divided by x minus 1 is 1. Remember, anything divided by itself is 1, and that's going to be really important in our next example. So if I look at this, what am I left with? In the numerator, I have all these 1s times x minus 2. In the denominator, I have all these 1s. So I could write it like this, or more typically, it would be just x minus 2. In our third example, okay, the thing I want to point out is that this is a division now. So how is that going to change it? Well, what changes is we don't like to divide by a fraction. Instead, we like to multiply by the reciprocal. So I'm just going to show that this instead is going to be multiplied, our first fraction multiplied by the reciprocal of our second fraction. We always take the reciprocal of the one after the division. So I'm not going to look at this anymore. So now it's just like our first problem. I'm just going to have to do a lot of factoring. In the numerator here, it's just a trinomial. Okay, so I'm going to get a plus 5 and a negative 3. Again, it gives me a negative 15 and a positive 2. In the denominator, I have my x times x for my trinomial. I'm going to have a negative 9 and a positive 5. Okay, multiplies give me negative 45, adds to give me negative 4. Times, and now I'm going to look at this new fraction, the trinomial of x and x. Okay, I know this is going to be a 9 and a 4. I'm going to need a negative 9 and a positive 4. And in the denominator, another trinomial, x and x. I need a positive 4 and a negative 3. And again, I can just look at this as one big fraction, a numerator and a denominator. And I'm just going to start reducing. X plus 5 gives me a 1. X minus 9, 1. X minus 3 is a 1. X plus 4 and x plus 4 is 1. Now the reason I wanted to show an example like this, it doesn't always happen, but if everything reduces, it does not equal 0. Most students write 0 and I have to mark it wrong. Remember, anything divided by itself, remember the numerator and the denominator are equivalent. They're the exact same, which means I get a solution, or a final answer, of simplifying it to a single 1. Let's look at our last example. It kind of combines both a division and a multiplication. There's lots of ways to do this, and if you feel comfortable, you can do it all basically in one step, rewriting it all out. It's however you want. I'm going to kind of do it in 2 steps. I am going to factor this right away, just so I don't forget to do it. I have an x plus 3 times an x minus 3. That is a difference of 2 squares. In the denominator, I have a GCF of 5x. And remember, always look for a GCF first. Many students get to this and they start factoring like a trinomial with 2 sets of parentheses and they can't figure out how to do it. So look for your GCF first. This is going to give me an x plus 2. Alright, I'm going to leave the division right now because I'm going to deal with that second. I'm going to look at this as one big fraction first. I have a GCF of 4x. I'm going to factor that out and be left with an x minus 3 times, I'm just going to look at the numerator. Again, it doesn't matter what order you do this in. This is a sum of 2 cubes. So if you remember, this is our little parenthesis and our longer parenthesis. X times x times x is x cubed, plus 3 times 3 times 3 is 27. To get my second parenthesis, I'm going to do x times x, which is x squared. My middle term is x times 3, which is 3x, but I'm going to do the opposite sign, so it's a negative 3x. And then 3 times 3 is 9. In the denominator, I have a trinomial, so I'm going to have an x in my first parentheses, an x in my second one. I'm going to have a negative 3 and a positive 2. 8x squared, remember that's a single term, so you can't factor a single term, so it stays as 8x squared. So, again, I'm going to have x plus 3 times x minus 3, and then 5x, x plus 2. I'm just going to hold off for this for a second. And now I'm going to start reducing. X minus 3, x minus 3. I always like to start with my parentheses. None of the other parentheses will reduce, but I have a 4x in the numerator and 8x squared in the denominator. So I'm going to look at them separately. A 4 and an 8 becomes a 2. A single x goes into an x squared. X times in the denominator. I have an x left in the denominator. So now, if I look at what I'm dividing by, I'm going to change that to a multiplication. And now I'm going to take the reciprocal of this fraction. Anything left in the numerator now becomes in the denominator. I'm just going to rewrite everything out. And please take the time to rewrite things out. Most students make a mistake because they just kind of leave it up here and try to do it in their head, so just be careful with that. And anything that's left in the denominator, I always like to put my numbers and my single, anything that's not in a parenthesis, in the front. So I have a 2x and an x plus 2. So now I can compare. Again, I'm multiplying these together, so it's like one big fraction. Let's see what I can reduce. X plus 3 and x plus 3. X plus 2 and x plus 2. If I look the rest of my parentheses, nothing reduces. And remember, a lot of students try to, when they use the formula for factoring a sum of two cubes or a difference of two cubes, they always want to factor this more. Remember, this will not factor more, so just leave it as that longer parenthesis. And now, so none of the parentheses reduce. I have a standalone 5 and a standalone 2 which don't reduce, but I have this x in the denominator and x in the numerator. So now let's see what we're left with. In the numerator, I have a 2, and it's typical that we put our numbers first, and an x minus 3. In the denominator, I have a 5 and an x squared minus 3x plus 9. If you need to, if something's left over, circle it. That'll help you so you don't forget it when you're rewriting your final answer. A lot of students on a test will have this 5 here and completely forget it, or they'll cross off the x a little bit bigger, and so they think the 5 is crossed off as well. So this would be my final answer. I hope you feel a little bit better about multiplying and dividing rational expressions, that you feel okay with simplifying rational expressions by looking at factors and not terms, and you feel comfortable with the multiplication and division of rational expressions.